Okay, so let's start lecture 2. It's on object-oriented programming, which is really the start of this particular course. And in order to talk about what it is, we actually have to talk about what it isn't and how it compares to other programming languages. A lot of people learn C and C++, and they think because they're called an object-oriented programming language, that they're actually programming in an object-oriented programming language. Sure, you might be. You might be using a language that has those features. But unless you're actually programming with objects, particularly a class as a structure, if you're not creating any classes, I'll tell you, you've never done any object-oriented programming. You may have used functions, you may have used other programming techniques, but until you actually create an object, you haven't done it, which is kind of the focus of this course. That's why the course is actually called Object-Oriented Programming in Java and not Java Programming. Obviously, we have to talk about both, but the focus or the emphasis is on the object concept and what makes it object-oriented. The good thing about Java is you can't program in it in any other way. You're stuck. You have to use object-oriented methodologies. If you don't, you can't do anything. So if you're looking at the slide set and you're kind of wondering, well, what's a procedure versus an object-oriented programming? If you think about the old days, things used to go from the top to the down to the bottom of the source code. You'd start out normally with a function, sometimes called a module, sometimes called a function, sometimes called a procedure, depending upon what language, if you were using Pascal, if you were using C or C++. C or C++, which most of you guys are probably familiar with, it's a function. It's a functional-based language. Where you create a function, you got main as the main function. And the thread of execution for the program starts out in main. And for the people without a programming background, you have to kind of assume certain things and take it for granted. Why they call it main, I don't know. Why they call it a function, I don't know. But, a function essentially in the old days was to make it so you didn't have to repeat work. So let's say you had to do a major math calculation. Well, you would write a function, write the code one time, save the function, and then call the function within the code over and over again. So every time you had to run a month-to-date sales calculation or something, you just call the function. So in the C or C++ and other languages, you start out by creating a function main. Inside of main, you call functions over and over again. And basically you have sequential execution of code from the top of the source code to the bottom of the source code. And that's actually called procedural programming because it's running through procedure after procedure after procedure. And it doesn't utilize any object-oriented anything. It's not, it's as far as you can get from object orientation. So the unit of the procedure is the function, and it's the functionality that's happening. And in the object-oriented world, we talk about classes. We don't actually have functions. Functions turned into methods. And I'll talk about that in a few minutes. But the main source of execution is actually the class. And in terms of object orientation, class equals object. I'm actually going to bump ahead a little bit to the next slide and come back to this one for a second to give you some definitions. So the class refers to the blueprint of the object. So we can't create objects when we're programming. When we're programming, and I'm stressing the terminology because what ends up happening is you see it over and over again. If you're reading a tutorial, you're listening to a video or something, it's going to say the object, the class. Anytime anyone ever talks about a class, they're writing source code. They're not running a program. They're not working with the application. If they start talking about objects, they're working with the application. It's a higher level of abstraction. So we have the blueprint. It's called the class. And the class is self-contained, and it has its own identity. So a class is a separate kind of concept from other classes, which are different types of objects to get into the object concept. The object itself is an instance of a class. When we write the source code, we have absolutely no objects. When we run the source code, we create what's called instances of objects. And that's when we use the class and we create a new instance, existence. I think of it, kind of sounds like existence actually, instance, existence. Could you do me a favor? Could you shut the door that leads into this room? Because I'm finding it already a little bit challenging to talk over the talk in the back. All right, back back to the lecture in progress. All right, so each object has a class which defines its data and its behavior. In Java, every object is a blueprint of one class, so objects don't take on multiple identities of different classes. And actually, the inheritance is single line as well. Each class is inherited from one other class. So it's a single line kind of process, single line kind of identity. And so what we normally try to do is build a hierarchy. This is where the concept of reuse comes into play. Because everyone talks about object orientation, say, oh yeah, reuse. Well, what is reuse? Well, reuse is when you develop, you write a class, however you want to describe it, one time, and you use it over and over and over again. And in the part 3 of the video, I've developed a class called employee. So once I've defined what an employee is, I can make objects of those employees, instances of that class. And I can actually have an employee Bob, an employee Mary, employee Joe. And every one of those instances have the same type. They're all of type employee, which comes from the object class. It basically represents a certain object. And then I can create another class and call it boss or supervisor or independent contractor or something else. And then that represents a different type. It's no longer an employee, it's a supervisor, or it's a this or it's a that. So what we end up doing in object orientation is we create a bunch of objects. This is the big picture is we create a bunch of objects. We take those objects and we have them interact with each other. And right now you're thinking, well, this sounds weird. Actually, when I started out my programming career, I started over at, well, now it used to be called Xerox, turned into Park Place, turned into Object Share. Long story short, I worked with a language called Smalltalk. And in Smalltalk, it was developed by, well, I can't remember, Odell Goldberg was one of the developers that I worked with, who actually, the language itself, believe it or not, was developed to teach kids how to program, to teach little, babies playing with building blocks how to program software, which is kind of weird, but essentially it kind of goes to the root of child behavior with blocks. So you take a bunch of blocks and you put them together to build objects, kind of like Legos, a lot of different ways. So building on the Lego concept, if you think about writing Java programs like Legos, you're on the right track. Because you got this piece of Lego, that piece, you got a green block, a red block, a blue block. You create these, you bring these blocks in and you stack them on top of each other, and voila, you're done. Here's your program. So it's kind of like that, but it's also, obviously it's a running program on a computer with functionality. But if you think about the way programs run, they store data, they manipulate data, they take I/O, input, output, they process something, they run through an algorithm. Essentially, you create building blocks to do this. You have one object that prints stuff to the printer. You have one object that prints stuff to the screen. You have one object that does something else functionality-wise, and you put all the objects together. That way, next time you need to have functionality to print something, well, you call in the print object, or you call in the I/O object or something. And Java itself, as a base language, is built from a library of built-in classes that already gives you the basic functionality. So we have system I/O libraries, which are nothing more than classes. Everything in Java is a class. They're all objects, even the base library calls. So they're not really like function calls. So most brand new Java people, all of a sudden they start calling them functions. Well, I need what's the function to print to the screen? What's the function to get input? And then you're thinking kind of wrong. You need to bring in an I/O object to get the output, to send output. You need it for input. And we'll go through all of those as soon as we start writing programs. But I have to actually cover the basics first before that. So let me slip back to slide number 1 here again. So procedural programming, also concentrating on creating functions, which we've seen. Object orientation starts isolating out the classes, which is kind of the biggest problem. I would say the biggest, most challenging part of designing an object-oriented program is figuring out which classes to create. Do you want this class, that class? So that's when design actually becomes part of the picture. So you might actually kind of see some titles that say object-oriented programming, and then you see object-oriented design. OOD, OOP, all these other different acronyms, because design is a separate field in itself. Software engineers spend a lot of time doing design work, and those are the guys who are really good at figuring out how many classes do we need, how should we break out the functionality. And it's not a matter of just sticking stuff in different buckets or creating a different module for this or a different module for that. What you're trying to do is look at a big engine that's running and try to define the subcomponents of that engine and then package it all together into some running program. So there's a lot of different concepts that are associated with that, which is really the true focus of this particular course. We'll look at programming, we'll also look at the design component. And you see some examples at the bottom of the screen, some colors. I don't know if I'm standing in front of it, I'll move away a little bit here. Figure 1 and Figure 2, don't worry about that yet. I'll talk about that in a few more minutes. But there's different ways of actually creating objects and different ways of creating and running procedures. And what you'll find when you're writing true object-oriented programs, you have a bunch of classes, you have a lot of imports, and I'll talk about that in a few minutes, where you're reusing a lot of classes that have already been created from this huge repository of all stuff written. And your program is about that, well, it's about 5 or 6 different lines. You're creating, if your program is longer than a page, if your main program is longer than a page, you're really, and if it's like a medium to small size program, you're really not taking advantage of all the opportunities that you might actually have in front of you. So we'll talk about that a little bit too. And so let's talk about the class, the object, which is actually today's focus. And it kind of sounds like, why are you just going to talk about objects today? Well, unfortunately, the whole problem with students learning object-oriented programming is they try to brush through this stuff easily. They try to rush through the beginning. I want to start writing code. I want to start seeing this work. And if you don't understand what an object is, you can't understand anything else. You're not going to get anything else associated with object-oriented programming. It's just not going to work. So unfortunately, I'm going to spend the entire lecture today talking about the object concept. All right, so objects. Objects hold data, and they have functionality. So if you're reading an object-oriented design book that's talking about, in fact, a lot of the UML, Unified Modeling Language books, a lot of the theory about object-oriented design. I was talking about communication. It's talking about data members, member functions, all these kind of different terminologies. Long story short, the old days we had data, and then we had the processing of the data, and we had procedures. So we define a bunch of variables. And if you don't know what a variable is in concept, not a bad idea if you're brand new to programming to pick up a basic like the deedle and deedle text, because you will need to pick up something like a variable as a concept. I'll talk about a little bit, but I'm going to go through it way too fast. So in the old days, we at the top of the program, integer this, double that, float that. We have a bunch of variables, and then we have a bunch of procedures or processing, all the functions and all the steps, all the if, then, the else's, all the iterations, all the flow control happening in the program. And that's pretty much our design. That's a standard traditional procedural approach. In object orientation, we take all that stuff, we put it together, and we put it inside of an object. So an object holds its own data and has its own processing of that data, and it has its own communication with other objects. So you can actually break the object out, and it's not on the slide, but you can actually break it out into 2 components that are separate, which would be the data and the processing of the data. And the data is actually referred to as, and some people call them class members, data members. On the slide here says class members, and class member, meaning it belongs to the particular class or object, fields, methods, and then nested classes and nested interfaces. And because a minute ago I just said, well, you can only have 2. There's actually 3 components to it. There's the data, the processing of the data, and then for more advanced people, you can start nesting stuff in there as well. You can start nesting subclasses inside of there. And you can start building on the concept. For us, when we start, we're just going to have data and processing. The data is going to be data members. I call them data members. They're nothing more than variables. Variables hold data for the class. And then there's this word called method. Methods are messages or functions. So if you come from a C, C++, you're familiar with the function, you already know how to write methods. If you've got no exposure at all, think of a method as enclosed, housed functionality. And they come in two different forms, accessors and modifiers, which is kind of the standard way of describing it. It doesn't necessarily mean that that's the template that you have to use, but usually the methods are either going to get behavior or they're going to set. So a lot of textbooks actually use set, get, instead of accessor modifier. Some actually use, even different terminology on that. And I'll tell you that's probably the most confusing part of learning how to program in Java or how to program in object orientation in any way. It's not standardized. So everybody uses their own terminology for almost everything. However, the concepts are all the same. In fact, every object-oriented language follows the same object-oriented methodology. So if you learn how to do this in Java, you can pick up another object-oriented language and pretty much know how to program in it from an object-oriented point of view. Okay, going back to class members. A class member, in terms of a field is a data member. I don't actually like the word field. I actually like to call them variables, which is kind of wrong. I mean, they're variables, but not in a traditional sense, they're not variables. Because I think variables are more something global. Like in a program, you have these variables and they're global for the entire, or they're used in this function or used out. But data members is my second choice, and I always try to remind myself, well, you at least say data member, because it's data that's a member. Members is an important word, believe it or not. I know it sounds like junk science, but it's an important word, because it's really a member of that object or that class, and it belongs to the class. When you make an instance of that particular object out in your main, and main, I don't actually like the word main, I call it driver. Because it's really the driver program. You'll see a lot of textbooks call it driver class. It's nothing more than a method that's main. And main is kind of C, C++-ish. But it's actually called main. We'll see it labeled main. Long story short, in the driver, when you make an instance of a particular object, it's going to contain these data members that belong to the object. They don't belong anywhere else. Each instance of every object is going to hold its own values. So going back to my employees example, if I made employee Bob, employee Joe, employee Smith, and we'll make some objects in a few minutes. Each one of them has its own name, its own salary, and they're all different. So if I change one object's name, it doesn't change the next object's name or the next object name. And if you think about it, if you look at people or building blocks and things, they are separate units. You all actually are inherited from human. Some of you are male, some of you are female in nature. Some of you have brown hair. Actually, all of you have black hair. Bad example. Some of you have different, some of you wear glasses, some of you don't. Some of you are short, some of you are tall. Those are what are called characteristics or properties. So what we do with the objects is we say, well, employee, what characteristics or properties? And properties is the word I like to go for. Properties is nothing more than another word for data member. For data, for variable, if I work it backwards. So for an employee, some of the data members I would have would be name, salary, hire on date, stuff like that. All characteristics that would describe an employee. I wouldn't put anything in that employee class that didn't belong to the employee. And I wouldn't put anything in there that was like not needed, like something that would have been assumed or something of that nature as well. So one of the things we do is when we figure out, well, we want to create a class, what are we going to do? We start out with the data members. I like to put the data members like right in the beginning, at the top. And I'll go through the class format in a few minutes. But a lot of people like to put them on the bottom. The other thing we have to think about is the functionality. What are we going to have this class do? And those would be the methods. And actually, I like to call them methods. So I agree with the slide set. I don't like to call them fields. Those are data members. Methods. Some people actually prefer the word messages. Methods, because really that's what you're writing. And I said before, a method is a function. So a method is the behavior. It's the executable code that the class is going to do. So if I had an employee and I was going to write some methods, I'd probably write some of what I would call the accessors and the modifiers, or the get and the sets, which are different variations of the methods, which would, give this employee a raise, give this employee some time off, capture some information about the employee, tell me a little bit about their health insurance. So what I'm doing is essentially setting information, and the information I'm setting are the data members, are those variables that are for each one of the individual instances. And so essentially what we're doing is creating these instances of objects, running the methods, changing the variables that are inside of that class, data members that are inside of that class. And that's our process. That's what's happening in our program as we're running it. The other third component is those nested classes and nested interfaces. I'm going to skip that for right now. We'll definitely get to it in a few minutes. But here's an example of what I'm talking about. Here's a sample class, and hopefully you can see it. Oh, that's really nice, actually. Kind of big. It's on a white background, so you can see it. If you can't see it, I highly recommend sitting up closer. That way you can hear me, and you can also see the board. So now we have a pencil. So I'm hoping that some of you might be able to recognize the data members from this slide set. And there's 1, 2, 3, 4 of them. 1, 2, 3, 4 of them on the top. And for right now, forget about the words public. What we're looking at, and I'll just take the first one as an example. Okay, I can't talk over people in the back. I'm sorry. Okay, thank you. Public string color equals red. Well, that's just kind of an interesting thing to do here. We've actually, and here's where experienced programmers are going to be bored and brand new programmers are going to be, oh, thank God she's discussing this. Okay, here's the stuff for the brand new people who've never programmed before in your entire life. What we're looking at in the top, those first 3 lines up there, is we're doing some variable declarations and initializations all in one shot. So we're declaring variables. We've got 4 of them sitting up there. We've got color and, here's a pointer here. So right here where it says color, that's the name of the variable. And length is another name. Diameter is another name. And what we have right next to it, I'm kind of working backwards through the declaration, is we have the type. So this is a string type, which means it's going to hold character data. Because I've said equals here, I'm actually assigning or initializing the variable to a particular value. So this variable, when I create it, color, is going to automatically by default be red. And this is actually going to be for everything. We haven't talked about constructors yet. That's actually a different type of concept. And then down here I've got integers, a data type, length is the name of the variable. I've just done a declaration, I have not done an assignment. Underneath I've got float diameter. This is where I say pick up a how to program in Java DDL and DDL text. He'll go through each one, and I'll probably do a video on YouTube about it. Each one of the variable types. Why do you want to use a string versus a double versus a float versus a, all of the other options? There's actually not too many. There's only half a dozen or so different variations. Whether you're going to store a number, whether you're going to store a string. And then I'm going to go through public in a few minutes, as well as the word static, which is actually kind of important as well. And so let's skip the first part where it says public and static here. And then we have long. That's another variable type. Next ID is equal to 0. We're initializing it to 0 because we're going to keep IDs for the pencils. I don't know why. And then we have a method. And so the method that we have is called setColor. As I mentioned before, we have methods that set behavior, methods that get behavior. This is sort of a work in progress class. It's not really doing anything. We only have a method, one method that's setting a color. Well, we're only working with a color red here anyway. And the part of the method which a lot of people who have C or C++ programming experience is really going to enjoy is the fact that it looks like a function. And the function takes on a parameter. And the parameter that it's taking on is inside of the brackets that are associated with the function call or the method call. And there's not too much of this terminology for brand new people that you'll have to go back and look up. But look up the word parameter if you're looking stuff up. And here we just have another variable declaration in here, string, new color. So this particular method, when we call it, and we'll see an example of it in a few minutes, we're going to send a new color to it. And it's going to be a string. It's going to say blue or red, or actually probably not red. It's probably going to be a new color. And the interesting thing to note about this particular class for brand new people who have never created a class before, it's using a data type called class. And class is actually a data type. When you create the class, we call it a class. Here I've left out public, private, and protected in front of the class. Actually, that's my next topic I'm going to talk about in a few minutes. But we have an opening and we have a closing bracket for the class. Down here is the closing bracket, up here is the opening one. And inside we have a method that is nested inside of the class. Most important thing to get out of today. If you're tuning everything out because you're like, oh, I know how to do this stuff, I've been writing classes for years. Lo and behold, the biggest problem that most students have is they forget everything goes inside of the class. Everything must go inside. I tell you, I see source code, I go, why did you put that method outside of the class? It belongs to the class. It goes inside of the class, which means don't write it underneath it. Because if you're a C or C++ person, you know function. You don't like nest a function inside of a function. You put function, function 2, function 3, and all those functions are outside of main. You don't put them inside of main. You know, we've already been trained to keep everything away. Now I'm saying forget all that stuff. Put it all together now. Put it all inside of the class because that's where it belongs. Everything that belongs to pencil is inside of pencil. Good idea. Okay. Okay, so let's take a look a little bit more here. I've already talked about field declarations a little bit in the previous slide. And this is more along the lines of what I said with declaration and initialization. If we call them fields or variables or data members or whatever we want to call them, the color, the length, and the diameter and the next ID, those are our fields. We've declared them. And the type of the name follows it. In fact, this is just pretty much a printout, a text of what I just told you a few minutes ago when I ran through that source code. But for those of you who want a little summary of it, optionally, you can initialize it. But you can declare variables, and you'll see it mostly declared without initialization. Because it makes no sense, actually, to initialize variables, because then you're not really using the class. I mean, you're not using the functionality of the class to set those variables. You're just setting them automatically. You might as well not use them. And another caveat just to be aware of as well, these variables, color, length, diameter, are only have focus, hold on a second, only have focus, only have identity inside of the class. Outside of the class, in the rest of the program, you know, in the main program, they're lost. We don't see them. Yeah?
If we have to differentiate between float or double, we use the alphabet like F or Q. Is there any criteria to differentiate between each and
Very good question, actually. No. She asked whether there was a particular order that the variables or fields, data members, whatever you want to call them, should be listed in. You know, should you put the floats first, integers first, should they be alphabetical? I don't believe there's a standard about that.
No, my question is
Oh.
like if you have to declare some variable with float and initialize some, we have to give some value with right 0.0f. It's a float value.
Oh, do you have to specify the data at the end?
Yes.
It's an optional thing, actually. Java will take it both ways.
Yeah, otherwise it will be taken as a double.
Yep.
If you won't describe that.
Believe it or not, and this is very poor programming practice, you don't even have to specify the type. It actually does its own initialization and sets the type automatically in the JVM. So if you actually said length and you gave it a double, and here it's an integer, it'll convert it to an integer for you. It'll actually assign it. Other languages, it actually might come back with an error message sometimes and says, hey, you know, type mismatch or something. Actually, C++ will come back with a type mismatch. Java will let it go, which is really bad. You don't want to do that. I mean, and also if you leave out the data type completely, sometimes it actually works for you depending upon the situation. So no, you don't actually have to convert you don't have to convert it. You can typecast it, and I'll talk about that later in the course. But yeah, good question as well. Different question, but good one.
I have read like you have to.
Yeah, you don't have to.
Okay.
You don't have to. In fact, you can assign it the wrong thing, and it'll convert it for you. So. Other languages, no. Other languages, you have to convert it correctly. To say that this is a strongly typed language wouldn't necessarily be true. But I'll get into typing later on. Actually, I don't want to confuse half the class at this point. So yeah, I think you understood my answer. All right, primitive data types versus object references. Okay, so traditional style programming, we all know about data types because most of us have tried to find the right. Is it a short? Is it a long? Is it a string? Is it a float? A double? What should I use? And there are many different theories about which type you want to use for which type of variable. And A lot of people get into the longs and the shorts and everything. You know, even the variable, even the, excuse me, I was going to say variable characters, but that's a type. Even the string type has different variations on it. We have that as well in Java, but we also have this thing called an object, which is a brand new type. So object is actually a type. We can send our objects as variables. We can create objects of different types. We can convert objects. We can do comparisons on objects and all sorts of different things. And we have what's referred to as an object reference. And I'll get into copy by, well, I'm not even going to go into copy, pass by value, pass by reference at this point. Everything in Java, if you are familiar with that concept, is pass by value, even though we're working with references. So it's kind of tricky. You only need to know that if you're trying to work with data and wondering why a side effect has occurred, why something has changed or not changed in terms of that. We have some tricky stuff to go over. It's not really, I shouldn't call it tricky. It's just different from other languages, I should say. So the declarations can be preceded by different modifiers, accessor modifier, static, final. So here we have a couple words called static and final to take a look at. And so now is actually probably a good time to start talking about private, protected, and everything else associated with it. If we didn't have inheritance, we wouldn't have to worry about any of this stuff. And if we didn't have a hierarchy, if we weren't trying to do reuse, we wouldn't have to worry about any of this stuff either. Here's the problem, or here's the reason why all of this stuff exists, and then I'll talk about what this stuff actually is. In Java, we build it once, we use it forever. Well, theoretically. If we're actually programming correctly, we have a hierarchy. If we're a development team, we've been working on this for years, we've made all these applications, we have a pretty decent repository. Each new application you build is that much easier and easier and easier. It gets to a certain point, hopefully, where you're reusing stuff. And as in your personal programming environment, hopefully you have a repository of saved up objects, these classes that you've created. So how do you preserve the integrity of the class? This is where private, public, protected, static, all this other stuff comes into place. One note, if you came in late, I see a lot of people actually have just arrived. Make sure to sign the roster that's going around. There's like 4 different versions of it. Okay. I'm sorry? I'll do it at the end. Huh. If they are putting it in uppercase? Oh, another reminder, if you're signing the roster, put your name in uppercase so that we can read it. We're trying to make a mailing list, and we can't read your name on some of the other ones that we've done. So, okay, let me get back. So these would be referred to as access control modifiers. So when we're building a class, as I mentioned already, we have these members, field members, data members, member functions, methods. Okay, theoretically, in a perfect world, all of the data should be private by default. All of it should be private and only accessible from within the class, which is what private's all about. So number 1 here, private. We've got private members are accessible only in the class itself, which means in the class, if we've declared some variables, and in our previous example, we declared some variables as color, length, diameter, this is what I'm talking about. We actually made them public. We probably could have made them private, and that would have meant inside of pencil class, we can manipulate that, we can change the values, but we can't do it outside. And now at least 1 or 2 people at this question are wondering, well, how are they modified? Well, we have some options. I haven't gotten into making these instances yet, but when we make the instance of this particular object, we're running those methods. In fact, we can run this method here that says set color. We can run other methods. It depends on what method is actually in the class, which is why we usually create a lot more methods than just one. The instance runs the method, so the method is what's used to change the value of those variables. The method inside of the class can alter, if it's private, the method can alter the values of those variables. But outside out there in main, we can't alter it, which means it's protected and only the class can do something with it, which is kind of interesting. But then it also poses a problem. What if you're inheriting a class from a class? We haven't talked about inheritance yet. That's further down the road. We have to have it viewable to people outside of the class. like to other classes that want to modify it. So there are other tricks that go along with that. Protected would be our choice here. Protected members are accessible in classes of the same package, in subclasses of the same class, and also in the class itself. So protected says, we're going to protect you from the public. And this is where we have, where's the public? The public is everybody. Usually the driver, that's why I like to try to put a name on that main. It's the driver program. Driver program is public. That's the public environment. And this is where all of the instances of all those objects are being created. Out there, we want to protect the integrity of those classes so people don't mess with something, change it. Because what ends up happening is we allow anyone to change a value of a variable from anywhere. The whole integrity of the class might be compromised. I mean, we might have functionality that doesn't work properly. If we inherit a class from a class and it's changing something and it's messing stuff up, we're going to end up with an issue as well. But sometimes we do want it to change. That's when protected comes into play. And then public on the bottom, public members are accessible anywhere the class is accessible. So if you want to be whole, open, no restrictions at all, you make everything public, which is why this is this way, actually. If you were, actually as a side note I forgot to mention, if you were to take and compile this class, it would compile just fine. If you ran it, nothing would happen. There is no driver program, it's just a class. So, because I had some people like trying, oh, I typed in that class pencil, but it doesn't do anything. Yeah, it's not going to do anything. We have to actually make an instance of the class. When we make an instance of the class and we run stuff, well, the only thing we can run is set color. That's going to do something. All right, so let's go back for a second and talk about the word package, second one on the list. And you know what? Don't worry if this doesn't make any sense to you right now. You'll see it come together. If you can just kind of, at this point, just rote memory, public, protected. Protected is, this. Protected is everything but public. Public is everybody. Private is just the class, nothing outside of the class. And then we have this package concept. Package concepts, in fact, you'll see it in the first Hello World program in the first video that you watch. You'll see, well, why do we have to make a package? Package members are accessible in the classes in the same package and the class itself. So we can actually use package as a key word and say, well, if it's in the same package, then we're going to let you access it. If it's in a different package, then you can't access it, or you can't modify it. You can still access it. So basically all this stuff means is you can read it, but you can't write it. So it's kind of like read, write. It's kind of like Unix when you put read, write, execute permissions. It's a form of permissions called access control. In fact, I think the same word is used in Linux, access control variables and things, to files and directories and stuff. All right, so let's take a look here. The top is, hopefully you can see that. It looks pretty good. The top is our pencil.java. Another note to say to the brand new people out there. When you cut and paste this code here, this is the code here for class pencil. It goes into a file called pencil with a capital P with a .java. Don't you think, oh, you know what, I'm in Windows, this has to be JAV, three-letter extension. No, you have to actually put JAVA in lowercase, actually. Very case sensitive, very picky, very picky. I don't know why so picky, but picky, because class pencil with a capital P is different than class pencil with a small p. Interesting. The reason why we have packages, actually, is so that we can have different classes with the same name in different environments. So we can have 3 or 4 pencil classes if we want, put them in different packages, and then we can run with as many pencil classes as we want. Have a whole case of pencils in different colors or something. Anyway, so. All right, so now we have create pencil.java in the lower box. In the lower box down there. And we've messed up the variables. I shouldn't say messed up. We've played with the variables a little bit. This is not the same identical code, I don't think. I think I had everything as public. We have a thing called private float price. I kind of changed one of the variable names to iterate the point here. We still have public, public, public. Everything's public except for this variable here called price. And what we're going to look at is here how to create an instance of this object and then how to assign a value to a particular piece here. So if we looked at the bottom, we kind of looked down here at the bottom. If we notice this code is not going to compile, we have a big X through something we've done wrong because we violated some of the rules. This is one of the best things about the Java compiler, is it will actually look at the public-private protected. It actually enforces its own integrity rules, which is why the system is in here. So let's see, if you're brand new to programming the command, in fact, you can do this yourself. You can cut these, paste them, put them in the text files, Notepad, don't use Microsoft Word. Go to a DOS prompt, type in javac, or put them into Eclipse. If you've got that installed, type in javac pencil.java, you'll get an error message on this actually. And here's what ends up happening in terms of, well, actually, pencil will compile just fine. The one that's not going to compile is create pencil. And you might notice that we have two separate files here. And if you are online and you take a look at my Hello World video, you see I put them, actually I put Hello World into one. And then I even put the employee class into one, which is not really good programming. And really good, if you're following the best standard, every class goes into a separate file. And you have many, many different files. If you put it all into one file, great, easy to keep track of, but you're sort of missing the boat on the concept. Because every time you want to use pencil, it's in the file that also contains create pencil. Maybe you don't want to use create pencil, but you got it anyway. So you got more than what you wanted. If you put everything in its separate file, and by everything I mean each class goes into a separate file of its own, you only use what you want to use. You don't get any of the extra stuff. And then you can overwrite the behavior and you can deal with it. Now, I'll talk a little bit more about that later as we get through the course. But to go back to here, we have two programs. One of them is the driver. The second one down here on the bottom, the create pencil, the brand new one you're looking at, is the driver program that goes along with this. Because as I mentioned before, if you compile pencil, nothing's going to happen. So here we have public class create pencil looks the same. Well, after you create about 1,000 of these, it's all going to look the same. Every class starts out the same way. That's all you're doing. All you're doing in object-oriented programming is creating classes and then running classes. Main driver is a class in its own. And actually what you see here in terms of this is you see main. You see void main. You actually have to have a main function inside of the driver. Why? Because when you're compiling this, Java knows which file is number one, which file is the first one. Because this is going to start the execution of everything else. If you don't have main, there's no starting point. That actually comes from C or C++. That was a kind of an artificial implementation of the same concept in this language. All right, let's reiterate the point here. This line here right above the X is it's a good line. This is going to create our first instance of our first object. The type that we created is called pencil. When we compile this, we're going to have two files. We're going to have pencil.class, C-L-A-S-S, and we're going to have create pencil.class. They don't actually have to both be in the same directory, believe it or not. If you're working in a distributed environment, they can actually reside on multiple directories, multiple computers. However, the JVM has got to be configured to know to look for it in certain areas. Right now, I would keep everything all in one spot. And when we start looking at applets, this point is really going to drive home because you're going to upload certain files and you're going to forget ones, and it's not all going to work. So don't think there's one executable file when you run this. And don't look for an exe file, you're not going to get one. You're going to get .class files. That's another question. And then I've actually had students ask me, how do you make an exe out of that? You don't make an exe out of that. Actually, you can. There's third-party utilities out there which are ridiculous. So Java is a JVM environment, virtual machine, and the virtual machine controls the execution of these class files. That's why you have to type the word Java to run it, and javac to compile it, Java to run it. I'll go through that. Actually, if you watch the first or second, the Hello World video, you'll see how that works actually live. All right, let's go back. So we have pencil P1 space equals new pencil. Going back to our declarations and our initializations, we've done it all in one. And we could have done that in two steps if we wanted to. We could have said pencil P1 semicolon. And if you're familiar with other languages, Java follows the C or C++ syntax actually for comments as well. So semicolons at the end of each line, opening and closing brackets at the beginning of each and the end of each method, and class. Pretty much the same kind of format. So that's why I say if you know C or C++, Java's easy compared. Anyway. All right, so we said pencil's the data type. It's an object. Remember I said we can have objects as a data type in Java. So we have pencil, P1. And here's where our interesting character comes in, is our new. New creates new objects. It doesn't create anything else. So new is used to create a new object. So P1 is now equal to new pencil. And for those of you who are brand new to programming, you're not gonna wonder. You're probably gonna just not be familiar with opening and closing brackets. The problem is, it's actually a function call, but it's an object, but it's a class. So if we had parameters, thank you. If we had parameters, we could actually, I don't know who did that, but thank you. if we had, wait a minute, let me just ask, do you guys have questions right now you want to discuss? Okay, go for it. Yes, it is. Correct. They're both different classes and different files, but one uses the other. Because when you run, in fact, when you run this, you type in Java space create pencil, and you would run the pencil class as your driver program. It's executable because it has main in there. It's going to look for the pencil class in the same directory. If you just have a standard Java install, everything should be, when you compile it, it'll be compiled into the same directory. It actually goes out and looks for it, finds it, loads it up, uses it, as if it were part of the same file. Nope. They can be in the same package. They don't have to be. I haven't even talked about packages yet at this point. And later on, if we had multiple pencils, we might want to create packages, because then we know which pencil are we talking about. Because we can create a package for create pencil, put a package in there and load everything into a package, essentially. And then, well, this is the package. Just think of it sort of like another layer in the directory structure. Think of it like, you know, we have a directory, subdirectory, subdirectory. When we start creating packages, we're separating out stuff and putting it into its own package or container, if you want to use that word, that isolates it so we can have multiple pencils, multiple versions of that particular, and we know which one. If we see the package, we know which one to go look for. As long as we make everything part of the same package, then we know, you know, and particularly these two classes should be belonging to the same package if we were going to use a package concept. But we don't actually have to, it's not required. You'll see with the Eclipse, it'll force you to. It'll automatically, when you create the new project, it'll ask you for the package name. So, and you'll have to, it kind of forces, Eclipse is a nice tool because it sort of forces you to follow everything and to do everything correctly. And if you'll see, actually, this third video, I talk a little bit about packages when I create the first employee class. So you'll kind of see that concept working a little bit. But I haven't even started talking about packages yet. Are there any other questions before I continue? Because I hear a lot of chit-chat, chatter. Yes? The funny thing is, if you say Java, if I were to reverse these steps down here, if I were to say Java C create pencil.java, it would actually compile both of them for me. Because what it happens is it goes and reads through line by line and says, pencil? Where is that? Goes and looks for, oh, here it is. Let me compile that one too. So by convention, this is wrong actually. By convention, you want to start with the main driver. That's why I call it the driver. Start with the driver, compile the driver. Because what if pencil is already in an object code format? It doesn't compile it. It just finds it, says, oh, here it is. Got it. Move on. Next one, next one. So it'll go through and it'll make sure it has everything it needs. Otherwise, it'll come back and it'll say, you know, can't find this class. Can't find this file. Where is it? Which is why when you have a directory structure put together, you create a project, you put it all together in the same folder. Every time you compile, it's kind of like C or C++. If nothing's changed to pencil, but you modified create pencil, it doesn't recompile pencil. It leaves pencil alone. In fact, it won't recompile any of the built-in classes either. And I do not recommend playing around with the built-in classes. Some of you, when you install it, you'll install the source code for Java because you won't know any better. I mean, you'll just pick all the options. If you run through the video, you won't install the source code or the database or anything like that, which you don't need, actually. Don't mess with the source code files. Yeah, a lot of people like to do that. It's all in Java. You can actually mess with everything associated with the language. Just leave everything in the bin directory alone. Leave all the library files alone. That way you ensure the integrity of the entire system. So, any more questions before I continue? I like when people raise hands too, because then it lets me know. Otherwise, I just wait for the chit chatter to start. All right, let's go back down here. We have a huge error message here. We have p1.price is equal to 0.5f. And as you pointed out, it's a direct cast to say, well, it's a float. You put that f there. This is actually kind of for C++ people. We don't even have to do that for Java. I could have left the f out, but that actually is your point right there. You can still do it, but you don't have to. But what's wrong with this? It's private. Yeah. Up here we said private float price, which means we've done this so that this can't happen. And what ends up happening is we get an little error message that says price has private access in pencil. In fact, that's what you probably will see. So just like any other programming language, as soon as you start compiling stuff, and if you're using Eclipse, this will appear at the bottom of the screen. You'll see those error messages and you'll get familiar with them. It's kind of like the type mismatch error you see all the time in C or C. Well, I see all the time in C or C++. This is one of the common ones. Is you'll probably take it and figure out, oh, we can't change the price. Oh, bummer. So, long story short. We have another one called static. And that's not all I'm going to say. I have more stuff on private protected, but I have to give you more concepts in order to so you can see it from a few different other perspectives as well. There's a lot to it. In fact, private protected is kind of ingrained in the entire language by concept, and it actually plays a bigger role in inheritance than anything else. Okay, so a little bit more on the variables. We saw the word static appear. In fact, static appeared right here. It's in the public, right beneath the float. Public static long next integer is equal to 0. Well, what's that all about? Well, only one copy of the static field exists, shared by all objects in this class. Oh, interesting. I just said, I hope if you were listening, in the beginning of the lecture, I said, well, data members, member functions, the class, all enclosed. You make an instance of the class. What ends up happening is that, you can change the name of the employee, the salary. For this instance, you can change it for this instance. You can change it for this instance. Sometimes in textbooks, those are called instance variables. When you use static, you've created what's called a class variable. More terminology. A class variable is a variable that's shared by all instances that are created of that same class. So if you wanted to keep track of how many employees you had created, you can increment that static variable, and you use the keyword static to change something from an instance to a class variable, data member, whatever you want to call it. And it's kind of a powerful tool. So you can be accessed directly in the class itself, not from an instance of the class, actually. In fact, you can take and direct it, you can actually change the value of that variable outside of all of the instances, which kind of blows the rules completely, but if you don't know the rules yet, it doesn't really matter. It's just, you learn it right from the beginning, you don't have to actually train yourself to think that way. So it's accessed from outside of the class. It must be preceded by the class name. So here we have pencil.nextID. What is this line of code? Actually, this line of code is kind of interesting. If you haven't done Hello World, you probably are not familiar with system out print line. That's basically your standard I.O. Go back, look at the Hello World video. This is how we print something to the screen. In fact, for those people who did look at the video, print ln, you could actually just say print. ln is line return. It's just like looking at, if you're familiar with C or C++, all of the system I.O. that you would actually get with that. You get that as well with Java as a different class you import. Actually, you don't even have to. It's already built into the functionality. So you call system out print line to print something to the screen. Here we're printing out the value of next ID. But we're not doing this from any instance that we've created. Instead, we're doing it from the class. So the class exists, and I don't know who had that question about the variables or the classes, using classes outside of the classes. And I forgot to tell you, actually, you can import as well. I haven't talked about importing yet. Another way, if you didn't use the package concept, is you could use import and import in functionality. So in this class, we're going to import to that class, and import to that class, and import that class, which is another configuration I failed to mention. So just thought it had occurred to me, actually, when I started looking at system output. But for system output, you don't actually have to import anything. But I'll talk about import next week. So anyway, or be an object belonging to the class. You can change it through the object. You can change it through the class directly. But the keyword static is what's making that possible. And just to reiterate the point, static here, long. If we said p1 dot, print out plong dot next ID, it would work. If we just said pencil dot next ID, it would also work. There's no limitations on that. So from outside of the class, non-static fields must be accessed through the object reference. So the object referencing is another point I probably should mention at this point. You've seen it in a couple slides already. It's this dot notation. This is what's referred to, this dot here. This is the terminology for that. It's an object reference. It says, from this object, give me this variable. From this object, give me this. And it's for variables. It's for running methods. It's for everything. So just one dot. It's not like C++ where we got the two semicolons. It's a little slightly different concept. We don't actually have that in Java. We just have dots. Everything's a dot for everything. So, okay, so we've got a couple of examples here. We've changed the driver program to make it a little bit more sophisticated. Before it had an error, we fixed the error. Actually, we just took it out. So now we have create pencil, and we have created a couple of different pencils. So here's another thing I usually have to mention, because usually someone will ask, do you have to create all the objects first? Because like people are trained in C or C++ procedural programming, all the variables up front, all the functions, or all the functions first, the variables last. You can create an object anytime you want, anywhere you want in the driver program. In fact, you can create objects inside of other objects too. You don't have to do it just in the driver program. Here we have P1. We didn't actually use any meaningful variable name. We could have called it pencil 1, pencil 2. And you'll also notice I didn't put too many comments in here, but this does demonstrate how to comment. And the comments don't show up in red normally. Actually, in your IDE for Eclipse, it'll be green. So you'll see it if you're successful. And you can use both the C or C++ kind of variation. So here we have pencil 1, P1 is equal to new pencil. That should hopefully look familiar. And we have pencil.nextID++. For you people who don't know programming yet, plus plus increments it. It's like saying next ID plus 1, next ID plus 2. That's why I say get a deedle text. You'll be up to speed with no time. System.out print line, P1. So this is going to print something to the screen. The result's going to print as 1. So now we have, we're leaving P1 alone. Back in the driver program, we're going to create a new object. We're going to call it P2. We can create as many objects as we want. There's no limitation. So we have, in fact, we're going to have a loop and create 1,000 objects. Interesting thing to mention, however, about objects and the running environment. I just said we can have a loop and create thousands of objects. We will eventually run out of memory. It's like a program that creates 1,000, 10,000, millions and millions of variables. Eventually there's going to be some limitation. Interesting thing about Java, however, is it does its own what's called garbage collection. And it will actually free up memory and organize the memory for you and give you warnings and things. So as you're testing and as you're running, I seriously doubt you'll run into, especially in your first Java programming environment, first programs you write, you're not going to run into this problem. But believe it or not, out in the industry, there are programs that actually have memory issues where you have to kind of strategically plan when you're going to create and use objects and how much data this object is actually carrying around with it. But long story short, the environment actually does everything for you. In C or C++, you heard about new and you went, oh my god, dynamic allocation. And then there's delete. There is no delete in Java. All you have to do is remember new, no delete. In C or C++, for those who are familiar with that, you were creating classes and you were using new created an object dynamically. If you didn't delete it, it stayed out there forever and took out memory. If you created 1,000,000 of them, your computer's going to pretty much freeze on you, or your program's going to freeze, I should say. And for that reason alone, I'll just mention it right now, if you're a C or C++ person, We had the constructor. We also have it in Java. There's no destructor because there's no delete. There's no nothing. So we don't have to worry about destructors. We don't actually have to worry about copy constructors either in Java. That doesn't exist either. But that's a topic for next week. Okay, let's go back. Don't worry about it. I am wrapping up in another 15, 20 at the most. So you're getting anxious. And I brought a watch with me so I could tell what time it was, actually. Because I know there wasn't going to be a time in here. Anyway. I know the attention span isn't that much. All right. Let's at least get through this. All right, so we have pencil 2. New pencil. We have another one. Now we're going to change it. We're going to go same code as before. We're going to print it out. Now we have 2. And now we're going to go back to 1. The code is interesting because it's telling you it changed it at the class level because it's a statically defined variable. If we go back and we do this P1 all over again, it's now going to come back and it's still 2. It's changed for everybody. So we can actually keep track of, let's say, employee IDs. Each new object of an employee that gets created in this program has an ID that's incremented from the last one. We can actually keep a running total through all instances of all employees that are created, which is different. But we can also keep information that's private to each one of the instances as well. So just keep in mind we have instance variables, we have class variables. The keyword static is the key to deciding which ones you want. And at the bottom of the screen you say this is only purposes of showing the usage of static fields is really poor design. It actually is poor design. But we'll get into why it's a poor design later. So you guys are already anxious to leave. But final. Finally, we got the final. What is final? Once initialized, the value cannot be changed. It's finalized. We're done. We're not done. We're done with this variable. This variable is done. It's kind of like saying declare in C or C++ or keeping something constant, a constant variable. So let's say we have pi, 3.14. Are we going to change that value? Probably not. Hopefully not. We're going to actually, if we declare a variable, call it pi equals 3.14, we're probably going to use the keyword final in front of it to say don't let anybody change this. Going back to the access methods, it's another keyword that protects things. And final, static, these keywords can be used anywhere. They can be used in front of parameters, they can be used in front of variables, they can be used all over, and you're going to see them all over the place. So often it's used to define named constants. If you're familiar with that terminology, what is that? Just constant variable. And a static final can be used together. They must be initialized when the class is initialized. So you actually, if you have something that's static, you have something that's final, you actually have to assign a value to it. And it has to be initialized, even if it's 0. So if you remember back in the previous slide, we said next ID equals 0. That's actually a requirement for the static. So that's another error you're going to run into the first time you write your own program and use the word static. It's going to come back and say not initialized. If you're going to have it available to all class, outside, you have to initialize it. So that's why a lot of programs actually get into the habit of initializing everything. Because at least when you print it to the screen, if you forgot to initialize it, forgot to assign it, it doesn't give you an error. It actually just shows you nothing. Or it says not initialized or something on it. So these are little keys you can put in there. Non-static final fields must be initialized when the object of the class is constructed. I think I mentioned that already. Okay, so here's some field initialization notes to keep track of in terms of the initialization. And a field is a data member or a variable. So it's more the terminology. Not necessary to be constant as long as it has the right type. We do have type problems, and there's, as I mentioned earlier, I alluded to earlier, that we had things that were automatically assigned. This is one of the things that Java will do. However, it won't fix your logic. If you're printing a non-string to the screen, you're going to get a non-string printed to the screen. And it's going to look like ASCII characters, numbers, and zeros and stuff, and it's not going to make any sense. It's not going to say the person's name. It's going to say garbage. And that's, you have a type mismatch error. It'll compile just fine, but when it prints to the screen, you're going, what's that? If not initialized, then the default value is assigned depending upon its type. So if you don't use final and static and you're using variables and you forget to initialize it and you print out the value, you're going to get 0. You're going to be, what happened? come it's 0? Well, because it's an integer, it defined a 0 type for it. So I will actually put together a video lecture that goes through different variables, different type usage. I think that would make sense, actually, because then you can see it actually running. Method declarations. Another note, I think somebody opened up the door. I'm hearing noise from the hallway again, I'm sorry. It's just distracting. Okay, we have method headers. In fact, this goes into sort of the concept of the function. If you're already familiar with a function, methods are declared, defined the same way. We define methods, we define variables, and inside of the method we actually put the functionality that's going to be performed. So it's not like an assignment or initialization, it's more like putting in the process of putting in the code. So it's consistent of modifiers, which are optional. We don't have to use the public, private, the access modifiers. We don't have to use any of that behavior. In fact, if you watch lecture 3, I was real sloppy. I left out public, private, everything. In fact, you'll see class something, integer something. You'll be like, where's all the there's no public, private. Because what the problem is, like, a lot of students get lost in the public, the private, protected, the static, define, all this stuff, and they don't actually figure out how to create a class. Because they're too worried. Or you go online and you start copying code that has protected this, private that, and you start using it, private for everything, and how come it won't print? Because the logic's all messed up. But anyway, long story short, it's optional. You don't have to use it right now. If you don't want to use it right now, you can get away with not using it just to get your feet wet. Eventually, you're going to want to use it because you can't grow. You can't actually move on from basic programming. I mean, it's great to create a couple classes, but what if you want to do inheritance? That's when everything's going to slap you in the face and go, oh, I never learned this. Oh, okay, then you're going to have to kind of learn it then. Type modifiers or access control modifiers. And we have a new one here. We looked at static, we looked at final, we have abstract. So the method body is empty. So abstract void sample method. It's just it's kind of like a prototype in C or C++, but it isn't. It's a little different in concept. I'll talk about abstract later on. But you'll probably go online and see abstract class this, abstract class that. Think of it sort of like a placeholder, sort of. Until we get to inheritance, until we get to a lot of other concepts. I'm going to save that one a little bit. Static represents the whole class. And no a specific object. Well, I think they should say not a specific object. There's a typo on the slide. And can only access static fields and other static methods of the same class final. Can't be overwritten by a subclass. This is probably looking like Greek to you, and I'm actually going to save it. Don't worry about slide number 13, the access methods. It's probably a little too early for it if you're brand new. But let's go to something you probably should be familiar with at this point, is that the dot notations I mentioned before. And here's another piece of terminology for you. Whenever you hear invocations, and I hate that word and don't use it, instead I say resolution, or I say reference. Method invocations are produced with a dot. So you invoke a method. You could say you invoke. Long form of the word is invocation. Nobody ever uses that word in real English. Well, maybe they do, but I don't. So invokes an operation on the class. We've seen it already. Here's an example where we have the reference, which is the name of the object that we've created, the instance. Dot some method with arguments. I call them parameters. You can call them arguments. This is information we're passing in to the particular class. We can have a static method or we can have a non-static method outside of the class. The reference, we've seen it before. It can either be a class name if it's static, as we saw before, which is this reference right here. It could either be a class name or it can be the name of an instance of that particular class if it's a static one. If it's not, it can only be a reference. And that'll make a lot more sense when you start putting this to use in the future. Overloading. Oh, I know you're overloaded at this point. You can also overload your classes. All right, a class can have more than one method with the same name. And I'm mostly looking at this probably going, I have a programming background. Oh my God, she's going to talk about overloading right now. It's actually not as bad as you think it is. It becomes more prevalent when we start working with inheritance again. But right now, you can actually be familiar with the overloading concept to one degree or another. What does that mean? You're just using the same class name. Excuse me, the same method name over and over again. Method names are kind of funny. You can have the same, so the class can have more than one method with the same name as long as it takes on different parameters. This is actually how we create our constructors. And to give you a little bit about what's going on next week we're going to talk about constructors, methods, start building some interesting classes. And when we start doing that, we start looking at, well, how does it know it's a constructor? Well, a constructor is a method. Everything is a method, there's nothing else. It's a method or a variable, one or the other. And it's a method with the same name as the class. And all the C or C++ people have been, well, if they've done classes, they're okay. If you have never programmed with object orientation in C or C++, you're looking at this going, you can have the same name. That's not allowed. And then you have to kind of break that thinking. You go, yeah, it is allowed, as long as you have different parameter lists. So, and to give you a little preview on a constructor is a method that invokes automatically when new instances of that class are created. So every time we make a pencil, we assign a value to something. We assign, or we get information from the user and we assign it to something, which is very handy actually, because what we're trying to do with the class is cut down on the amount of work that we actually have to perform. So anyway, here's an example of method overloading as a concept. It is called overloading because we're taking something and copying it or creating another, overloading the functionality. And so we have a set price that takes on a float new price, and then we have set price that takes on a pencil P. And this actually demonstrates a concept, however, of more object orientation. And this is actually where, and I can never say the word correctly, so I'm going to say it real slowly. Polymorphism. Oh, I think I said it right. Morphism? Polymorphism. Morphism. I don't know. I can't say it. Polymorphic. This can make a class polymorphic. Why? Because we can set our price to a float. We can set our price to a pencil, to an object, actually. We can have a print object that prints out a number to the screen. We can have a print object that prints out a text string to the string. So it polymorphs, it morphs, it changes, it adapts to whatever input that's given to it. It's another, if you were here for a pi, oh, I haven't done a pi yet. Have I done a pi in this class? No. Next week we'll do a pi. There's major concepts. Actually, no, not enough time. Next week I'll talk about a pi. Abstraction, polymorphism, is that right? Inheritance, encapsulation. All the different characteristics of object orientation. This actually is a demonstration, not on the slide, just a side note of that particular concept. This is how we create it. We make objects morph into what they need to do. Take on behavior that they need to take on. We can't do this, actually, in procedural programming. It doesn't work. We can't do, actually we can't create classes and have classes work like functions in procedural programming either, because classes take on both that data and also that method processing, so, or functionality. So how does a compiler know which method is going to be invoked? Well, it looks at the number of parameters, matches it up, and uses it. So the Java JVM is pretty smart. It can actually go through and figure out what it needs to run and run it, which is different, a lot different. So methods as parameter values, oops, it is being mentioned briefly. I'm going to talk a little bit more about this as well in the future. Parameters are always passed by value. If you have no idea what pass by value or pass by reference is referring to, you're lucky. You don't even have to know this at this point. Don't tune me out and do something else, because you don't have to actually grasp this concept. If you're a C or C++ programmer, this causes confusion, actually, because you're trained to know by value, by a reference. All this means is what information are you passing to the function, aka method, which we're heavily using with these classes. And if that particular variable, that particular object, whatever is being passed in, is it going to be changed permanently for that object, or is it only going to affect what happens with the class? Everything is actually by value in Java, but we can pass references to objects, or object references, which is kind of interesting. It kind of breaks its own rules a little bit, and you know what, I'm not even going to elaborate on this because I think it's going to be way too much for some of you right now. So when the parameter is an object reference, it is an object reference. It actually is an object reference, not the object itself that gets passed. So it takes a reference and turns it into a value, long story short. Which, yeah, it is a reference. Is it not a reference? Here's another example. Actually, I'm going to skip this concept right now. I've opted not to present it right now. So we're going to get out of that because I think it's going to be way over. So I only have 2 slides left for those of you who are getting antsy. So the main method. I talked about it already. I said I called it the driver program. If the class has a main, it's the driver. If you have multiple classes with main, you try to run them together, the compiler is going to come back and say, well, which one do you want? Multiple mains. It gets confused. So you only want one main. And just like in traditional C or C++, main is the start. So the main method, the system locates and runs the main method for the class when you run the program. If you actually accidentally run one of the other classes, believe it or not, it actually goes back and finds main. In some cases, especially if it's in the same directory. And then once you learn actually kind of how to organize all the classes in different files, where to put the main driver program, and how to organize everything, this makes distributed computing a cinch, actually. It makes your life a lot easier further down the road. Only method that gets executed when you call main is the method explicitly or implicitly when it gets executed. Must be public for obvious reasons. Static or void. I'll talk about static or void later on. Well, actually, void is nothing. Doesn't return anything. Oh, another note, actually. Most of your methods can return a value or they could not. A lot of C, C++ programmers learn how to make functions, and some instructors ingrained in their heads that every function had to return something, or return 0. In C or C++, in Java, actually, you can have a method that doesn't return anything. In fact, the constructor doesn't return anything at all. So, and we can have void. Void is now acceptable again. Anyway, so the main method, getting input from the command line. What ends up happening is the same thing if you're familiar in C or C++. This string argument that comes from the command line, we can actually get the string, and this is going to be an array of information that's typed in. Same concept if you are familiar with C or C++. If you're brand new to Java, again, go back to Deedle and Deedle. He actually, within the first chapter, chapter number 1 or 2, goes into the concept of string arguments. And here, essentially, it's just, believe it or not, sort of like an old-fashioned C program. In fact, a lot of mains look like C programs. They're just procedural. So the main is essentially where you can actually go back and have freedom to program like a C or C++ programmer. Because you're just making instances of objects and calling them, essentially. So, all right. A little note on the bottom, it accepts strings. In this particular example, not everything comes in the form of a string. It can be converted. Modifiers of classes, as I mentioned before, a class can have an access modifier. That's the public, private, protected, as we looked at. Just as a note, I don't want to leave you with the idea, just especially if you never come back, that just variables have modifiers. Classes also have them as well, and they mean the same thing. So you can go ahead and read through the slide. Essentially public, it's going to be accessible to everybody. Abstract is the different one. We can't use abstract on a data member, but you can use it on a method or on a class. That is correct. So normally a file can only contain multiple classes, but only one public one. Well, we're not going to use multiple files in this class, so we're never going to have to worry about that, actually. There are some people that do prefer to put everything all in one file. They're old C++ programmers who have converted to Java. So. All right, so that is the end of lecture 2, you guys.